Zoom in and out with your scroll
Yeah,
button?
so you use the scroll to zoom in and out.
Okay.
And then you can hold down on the scroll wheel to go up and down. And see dimension again, you'd be like, ooh.
Doing some learning
Ooh,
here.
55.
What are we doing, guys? Wow, show me those slides. Beautiful. That's David. Hey, headed to Boeing. No, it's about 2:44 because David picked us up at 2:39. So we're on our way.
But we're gonna be on time. It's only
So
gonna take
we'll
1
be
minute.
okay.
Boeing.
Look what we got because we went to Boeing. Wow. Yay! How was it, Thomas?
It was great. We learned all about the thrust reverser. It's quite big.
And being awkward.
Yeah, it's not Boeing, I'm not going.
The first thing that we worked on this quarter was creating a physical prototype, and that was made out of foam and cardboard, and we also 3D printed some parts of that. The process included we created a whole base with the foam, and we learned some technical skills that included using a hot wire to cut the foam, and then once we cut the foam and pieced that together, we had to create a translating cover that would go over the grill on our prototype. We ran into some problems with balancing the cover on top of the grill and having it tilt too much, so we kind of had to figure out where to put weights on the cover so that it wouldn't tip over. In addition to that, the flap that would go up at the same time as the cover moved back, it wasn't going back down because it wasn't heavy enough, so we had to kind of fiddle around with how we could get that down by adding more weights to that. And one of the other issues that we ran into once we put the fan on the front, we weren't sure how long each string should be, which was going to show how the airflow was going through the model. So we had to play around with those lengths, but we still weren't getting it, so we added a plastic wall on the side to make a more streamlined airflow through the model. That still didn't quite get the strings to be straight. They were still twisting up inside. So we created a 3D printed airflow grill to create more of a mini settling chamber so that the vortexes from the fan would be decreased. And that actually was very successful. So in combination with that plastic wall and the vortex grill, it let the strings like flow straight and actually showed what our model was trying to do. So that was pretty cool. Moving on from the model, at the same time Anna was kind of finishing up that physical model, I started the CAD, and I wanted to create something that was duplicate to the model so that we could in the future print that out or print parts of that out so that it would be a little more finalized if we would ever display it somewhere. David definitely helped me out with that, and I just became a lot more familiar with the overall software and how to extrude, constrain, import step files, assemble parts, and just isolate and drive different parts of that. So if you look at it, it looks the same as our physical model, but you're able to drive the cover and the flap at the same time, which was an issue we kind of ran into in CADing that. The issue was that we had to convert the degrees of lifting that flap 2 inches so that the cover would slide back at the same time, because before they were separate from each other. We kind of had to do some research and figure that out. Then I also had a lot of trouble CADing the grill that lets the air go through it and go back. One of our next goals is actually making each little set rib in the grill to kind of tilt so that the air could be more directed. But the first step was me figuring out how to create those just straight, and that was something that I kind of struggled with, but now I'm good, which was shown through how I started teaching Anna how to do CAD after that. After I completed the first CAD model, Anna wanted to learn CAD as well to up her technical skills. So I sat down with her and tried to teach her everything that I had learned, which was a challenge for me because I wasn't totally comfortable, but it really pushed me to understand what I had learned and teach her. And of course, David was there to help us along the way. And so in the future, some goals that Anna and I are going to be working on this next semester are combining the CAD skills that we both picked up with the build skills that we started with, and then create a final physical model that could maybe be displayed at the museum. We're not sure what that future is with them, but could at least be displayed here and have parts that may be 3D printed, parts that are built, and just have an overall nice slick design. On top of that, our hope is to possibly have a button that will allow it to actuate by adding a motor to a part so that it could move at the same time and actually show more clearly what a thrust reverser does on an airplane. So that is what we did this quarter. We had a lot of fun and we learned lots. Can't wait for next semester.
Here you can see the completed beta of the interactive display. This is the home screen where the user can begin learning about thrust reversal. If we start on the top left, the 3D model can be seen. It's a movable model, and right now it's not of a thrust reverser, but it's in our plans to CAD a model of a thrust reverser and put it into the display so it can be interacted with. Next is the embedded video footage. Down here we have put one video of a thrust reverser into the display. Right now it's rather simple, but we hope to implement a method of switching between different videos so we can fit more than one into this portion of the display. Videos could potentially show off different types of thrust reversers, or just them being used on various planes. The next part of our display is the actual information, which is contained in the linked gray boxes. By tapping on the gray box titled History, Evolution, and Types of Thrust Reversers, we can learn more about them. This screen is a scrollable interface with information on different types of thrust reversers. On the bottom, a timeline can be seen, and by scrolling and following the timeline, the user of the display can see how thrust reversers have evolved over time. Our next step is to create our own diagrams to replace the ones that we are currently using, and to better implement the timeline on the bottom of the screen. By going back home and tapping on the other box, you can access the other information screen. This page contains answers to the questions, what does a thrust reverser do, how do they work, and why are they important? The page also contains images and videos to help support the answers. There is even a link to return to the History and Evolution page. Overall, we have a solid working beta of our display with plenty of room to improve it next semester.